Buenas tardes, bienvenidos a la primera sesión que tenemos esta semana. Vamos a tener la sesión que corresponde al mes de junio, justo apurando para acabar. En esta ocasión, como sabéis, tenemos dos sesiones muy seguidas. La de hoy es realmente interesante porque vamos a hablar de programación imperativa o programación declarativa. Entonces, recordad que luego al final de la sesión también tendremos un pequeño sorteo para, pues para sortear algunas de las licencias de IntelliJ que tenemos, de JetBrains, y esto será después de las preguntas. Os dejo con Carlos, que ya en inglés, la sesión de hoy va a ser en inglés, entonces ya en inglés hoy Carlos nos va a presentar ya a nuestro invitado, que es un conocido ya de Madrid. Carlos.
Well, hello everybody. As you know, we have today Nicola here, who is an old known person in Madrid, because he visited us like 2 years ago, if I remember correctly. So this time the session has to be remote, as everything we have been doing lately. But we are all getting used to this. I'm not saying it's growing on us, but it's we are getting used to that. So we are going to do our best here to make Nicola feel like a home, like in Madrid again. And we are going to enjoy for sure this talk. As you all might know him, he self-defines as a Java geek, and he is working in Hazelcast. And he's going to talk today to how to go from imperative to reactive in Java. So without further ado, I will leave you to Nicola and his talk. So Nicola, whenever you want to start, the floor is yours.
Thanks a lot, Carlos. Hola, caballeros, caballeras, y amigos y amigas. And that's all the Spanish that I can say tonight, which is already a lot. So thanks, everybody, to be here for this talk about from imperative to reactive. Just a slide of introduction. I'm Nicola Frankel. I've been a developer for 18 years. Since 2 years, I'm a developer advocate, which means I probably work like code less than I did before. But still, I'm trying to code a bit every day. And most importantly for this talk, I want to emphasize that I'm not a reactive guru. I didn't work many years in reactive. I just wanted to understand how it works and some specific aspects. And so for this reason, I believe that if you are not like working in reactive yourself, it's a good talk because it can like lead you into this world. And it's actually, it's not from the bottom up. I won't talk about all the mechanics and stuff. It will be like a top down, like just I learned myself. I work for a company called Hazelcast. Hazelcast has 2 products, and though it's not the focus of this talk, I will be using it in the demo. The first one is IMG, in-memory data grid. If you've never heard the term, you can think about like distributed data structures. So if you have for example, an IMAP, a map. Now you can replicate the data across several nodes in the cluster, or shard it because it's too big. And the other one is JET, and it's an in-memory stream processing engine. But back to reactive. So reactive, depending on your subjectivity, might be like quite old or quite recent. But for me, it starts with the Reactive Manifesto, at least in the JVM world. And the Reactive Manifesto states that for a system to be reactive, it must has like four main features. The first one is responsive, meaning like as fast as possible. The second is resiliency, and this is quite important, meaning that if one like component of the system fails, it will still respond. Of course, it probably won't be a response that you are expecting, but you won't go into timeout because the system doesn't respond at all. The third feature, the third property, is that it should stay responsive, and that is very, very important in the current state of things, because of course the loads that we are putting on our system is increasing more and more. And of course, every system is responsive more or less, but the idea behind a responsive system is that they scale like close to linearly. It's not that they scale and then at some point they just like crumble. They should scale more or less linearly. And the fourth property is it's message driven, especially it's asynchronous. So you would just deliver a message and you don't wait for an answer, you just subscribe to an answer when the response arrives. And the third part of this approach is that the people behind this manifesto had something very specific in mind. And this very specific stuff was the actor model. So the actor model was popularized on the Erlang, the OTP platform. And actually you just have like actors, so-called actors. They would like be self-encapsulating, and they would share no state. So in order for an actor to like do something to collaborate with another actor, it would send it a message. Then the message would get into their like mailbox, into a queue, and then the actor would just like all the time would read it, execute it, or do whatever it wants, and then go on, perhaps pass another message to another actor, perhaps to the same actor, whatever. And again, the idea is there would be no shared states. And that is a very resilient pattern on the OTP platform. And on the OTP platform, when an actor, for whatever reason, just like is not responsive, then it's killed, a new actor takes its place. And for this reason, it's very resilient. And today, it's not the actor model that seems to have won, at least on the GVM. The current model that seems to be like the best, I wouldn't say the best, but the winner is Reactive Streams. And it still has all the properties that I mentioned before, but not in the same way. The architecture of Reactive Streams is basically you've got a main event loop. Oh, can you see it like this? Yes. You've got a main event loop, then you've got a message queue. Requests get piled up into the message queue, and one by one that get unpiled and dispatched to an event handler. And the interesting bit is, it seems like there is a single actor. So actor model, yes, it stays on the Erlang platform. It stays on Akka. Akka is based on the actor model, but Reactive Streams has this kind of design and architecture. Now the question is, why should you go reactive? Well, there might be good reasons for that, and I believe there are very bad reasons for that. You've all heard the fact that, hey, your system, so you design a system, and somebody who has no clue about it asks, hey, is it web scale? Because, I mean, when you have no clue about something, you ask, is it web scale? I have a statement for you. Most of our applications, they don't care about being web scale, because web scale is really web scale. So if you're not Facebook, if you're not Google, if you are not Netflix, if you are not Amazon, there are not many chances that you need to scale that much. I mean, I've designed, or at least I've worked on systems that needed to handle like thousands of requests per second. That's the upper limit, and we were in Reactive, and we handled everything perfectly fine. So if you want to use Reactive because you need to scale, well, probably you are over-engineering your system a lot. Now, something that might make, in my opinion, a bit more sense is about being cloud-friendly. As I mentioned, the idea behind Reactive is that you should never block. And the problem with blocking is that if you are on-premise, if you have all your infrastructure on-premise, that's not an issue. You have already bought the infrastructure. So if you are wasting memories because a thread is blocked, you don't care that much. But if you put all your workloads on the clouds and then you block, then basically you are consuming memory for no good reason. And that might increase your monthly bill a lot. So this is a good reason, at least, to take reactive into consideration, like decreased costs. On the other hand, of course, reactive has downsides. The first one is, in my opinion, a very, very complex mental model. Like, we have been taught to program, I call something, I get the response. And now the idea is, well, you get something and you subscribe to the response. And so now your mental model is not linear. It might get intertwined, and you need to reason, if I get the answer of this request before this request, I need to wait, and this kind of stuff. And it's let's face it, harder to reason about. For the same reason, if something bad happens, it will be hard to debug. I don't know if you, for example, had to debug lambdas, just like simple lambdas inside of IntelliJ, and now the debugging of lambdas inside of IntelliJ has improved a lot. But at the beginning, that was like, well, let's get back like 20 years ago and let's put like print statements just to understand what happens. Something that I believe is not mentioned enough, you've got specific APIs, and every reactive framework has its own API. And of course, they look very similar, but of course, they are not named the same. And even worse, that they might look the same, but have some slight difference in the execution. And that you need to be familiar with. And finally, if you have a call chain that is reactive and you introduce one blocking call in the middle, then your chain is not reactive anymore. So you cannot say, hey, my system is reactive. So every time you need to make sure that your whole call chain is reactive. And again, it's more effort. And so there are benefits, there are downsides, and it's up to you to decide if the return over investment is positive or negative, and I cannot answer for you. But just don't use reactive because it's microservices, because it's agile, because it's Kubernetes or DevOps. It won't solve your problems magically. It's just like an engineering decision, like pros, cons, and you compute if the ROI is positive or negative. Now, that being said, as I mentioned, the Reactive Streams API seems to have one, but it's really, really simple. The Reactive Streams API is only 4 interfaces. The first one is the publisher. The publisher will subscribe to a subscriber. The subscriber, in turn, offers like 4 methods on subscribe, and you will pass in a subscription. And here you can see that a subscription, you can cancel it, or you can request like n elements, meaning that the subscriber is the one that decides, hey, I want n elements. So you don't have the issue that you have a very fast-producing publisher and the subscriber just get drowned into the events, because it's the subscriber that tells, hey, give me X more events, Y more events. So when the subscriber has finished its current processing, it can request more events or not. Then, of course, you probably know about those 4 methods, as mentioned on subscribe. So at the beginning, you do this. Then every time you receive a new event, you call on next with the event. If something bad happens, you've got on error. And then normally it stops the processing. And then finally, if the stream successfully completes, so you've processed all the elements without any error, you call on complete. And as I mentioned before, because you will probably want to chain like different calls, so publishers and subscribers, so you will have probably 1 publisher and 1 subscriber, And in between, you will have stuff that's like subscribe to the next element in the subscribe to the next element in the chain and publish to the former elements. You need something that like bridges between the two, and it's a processor. And yes, that's the end of it. That's just the Reactive Streams API. It's pretty straightforward. However, those are only interfaces, and if I tell you now, you just develop something with that, well, it will be not that easy to do. So what we have is we have different implementation of these reactive streams. And because my demo will be based on Spring, I will talk about Project Reactor just in a few words. So this is an initiative that is led by Pivotal, or perhaps now it's VMware, Tensu, or whatever they call themselves nowadays. And it has no dependency on Spring. You can use Project Reactor without Spring. Spring, however, uses Project Reactor. And here you can see that the interface, the publisher interface that I showed you before, has in the Project Reactor API two implementation. The first one is a mono. A mono can like wrap 1 or 0 element, and a flux can wrap 0 to whatever, how many elements are necessary. And those two are publishers. Now, if you are a Gdk expert, you might know about this flow class in Gdk9. And if you look at the Gdk9 flow class, you will notice that we've got the exact same interfaces in a flow class. I don't remember the exact package, but there is a flow class that has all those 4 interfaces as inner interfaces. And on the Reactive Streams website, they tell, hey, false, no worries, at the moment, we don't have that class available yet, but at some point in the future, we will integrate it. It was like available in 2017, we are in 2021, this class is still not integrated. So I'm afraid that if you use Project Reactor, you will need to cope with these interfaces in the org Reactive Streams package for a while longer and probably forever. If you want and if you need to bridge between the Gdk9 Flow class and the org Reactive Streams package, you have this class available in Project Reactor, and you can go from one to the other. Now, I assume that you know a bit about the Spring Framework, and especially Spring Framework Web. And since version 5, which is already a couple of years ago, they support reactive type. And they actually have a dedicated module or project like that is entirely focused on reactive, and they have their own package. And so I also assume that you have been using Spring MVC in the past. And if you like followed the last changes, now you know that you can use Spring MVC with annotations that I've used for ages. That's a lot of people have used for ages. But there is something called Spring MVC FM that lets you use Spring MVC with functional APIs. You don't need annotation anymore, or let's say let's not like specific dedicated annotations. Fun part, with Spring Webflux, you can also use annotations. So you can reuse the same annotation that you were using before, just change the underlying engine, and it will be a reactive with Spring Webflux. And of course, Spring Webflux offers functional API. So while I think that the most straightforward way to move from Spring MVC to Spring Webflux is to just like change the underlying engine, I'm afraid if you are not used to Spring Webflux in specific and reactive in general, then it will be just the most straightforward way to failure because, hey, it looks familiar, but it changes everything underneath. So in this, in the demo, what I propose you is to move like from annotation to WebMVC FM, the functional API, and then afterwards here. So it's not straightforward. It's like actually quite complex, but I believe that if you are using Spring Webflux functional API, you will notice that something is very different because we have all been using Spring MVC annotation. So we are familiar with that. We think that we know how it works. And if we change how it works underneath, then again, it might be a big failure. So I've talked a lot. Now let's do some coding. So before this talk, I asked the organizer, folks, should I do the demo in Java and Kotlin? And they told me, so why did I ask them and not you? Well, the reason is because they reminded me that there is a slight delay between me asking a question and you answering. So I didn't want to juggle or do something stupid for 1 minute. So I asked them. They chose Java. If you are not happy with that choice, it's not my responsibility. You should go to them. You should tell them in the chat that was the wrong choice. Anyway, the good stuff is that on the GitHub repository, I have the code. The code in the main branch is Java. The code in the Kotlin branch is, of course, Kotlin. So if you're interested in Kotlin, you can check the GitHub repo by yourself. So let's start. So I've created a project. I went to start.spring.io. This project is perfect choice. Thanks, Rafa. So organizer, you made a perfect choice. That responsibility is yours. That's good. I created a project from start.spring.io, and it uses, I don't want a too simple project, but not too complex either. I'm using Spring Boot started Data JPA. I'm using Spring Boot started web. So I have just the controller layer. I have the repository data access layer. I will be using Hazelcast because I want my database entities to be cached because I have performance issue, or let's pretend I have performance issue. And as a database, I will be using an in-memory database. So my choice is pretty stupid because I will have an in-memory database, and on top of that, I will have an in-memory cache. But here it's just for the purpose of the demo. In general, you would have Postgres or MySQL or Oracle or whatever. I just wanted to have some caching. And the rest is just the Spring Boot Maven plugin, normal stuff. And so I designed my application around a person entity, and a person entity has an ID, which is its PK, first name, last name, birth date. Again, nothing really hard. It's just standard stuff. I have my repository that will fetch person entity from the database. And I didn't do any writes, but you could do writes. And because I'm super lazy, I'm using Spring Data JPA repository, which means I don't need to code anything. I just provide the interface, and at runtime, Spring Boot will use the implementation, the default implementation. That's perfect. And then I have a person controller. Person controller fetches one entity from the repository or all entities from the repository. Because I'm using Spring Boot, and again, I'm super lazy, I've already pre-populated a couple of entities, Joe, Jack, William, Averill, and Matt Dalton. And I've configured some interesting stuff. The first stuff that I've configured is I've configured the cache. That's quite easy. So I will be using Hazelcast. And the second interesting stuff is that I will generate the statistic just to make sure that I'm really using the cache, because again, I want the cache to work. And because Spring Boot integrates Hazelcast, I just need to provide this hazelcast.xml. Spring Boot will notice it at startup time, and I will start right now, just not to lose any time, and it will create a new Hazelcast node. If there are multiple Hazelcast nodes on the same network, they will be discovering themselves, creating a cluster here. I have a single application, so no cluster. Well, cluster of one node, which is pretty stupid. So here you can see when I start the application, I have the Hibernate statistics. The Hibernate statistics at the beginning, they are all empty, of course. And now I want to start doing something crazy. I want to curl, just to check that it works. So I will curl localhost 8080 person 1. Amazing, it works. Now, I'm a good engineer. I told you I was a coder for 18 years, so that's I can create a simple CRUD application. Now, let's look at something more interesting. We see that there was a cache miss. Of course, the cache is completely empty. I just started the JVM, and then like Hibernate, like prepared the GDBC statement, executed the GDBC statement, and put the entity into the cache. So now if I do the exact same query, of course, I got the same result, which is probably what you expected. And more importantly, and now we can see that I had a cache hit. So there was no GDBC connection or no preparation of statement or execution of statement. So now I'm reading from the cache directly, which is super cool. Again, I'm using an in-memory database, not very interesting in that exact case, but in general, pretty good. And that's great. Now, what I want to do is I want to go a bit further. And as I mentioned, I want to move towards something like that looks different to what I'm used to. And in that case, I will be moving to Spring WebMVC. So I will check out the repository. And I mean, it's pretty like easy to do that. The POM means here, I just change the, sorry, I just change nothing. It's still the same like component, the same project. It's just that I will be using a different API. And now you might notice that, sorry, I have changed my controller to something called rules. So here before I had something called controller, and here I had something called get mapping. Now I'm not using, I'm still using annotations, but they are not specialized annotation. They are normal annotation. So I just want this method to contribute to the contexts. And so it will put this rota function, which is this one, in the context. And again, the same likewise for this one. And here we can see that actually the get method is like requires a string, which is the mapping, and what they call a handler function. And the handler function here, sorry, is just like a functional interface, and it takes a server request and returns here, in that case, a server response. So if I get back here, I have my server requests. In the case, if I want all entities from the database, I don't use the server request at all. I will be just like creating the server response using a builder with OK, which will return a 200, and then I will put that into the body. And as you can see, here I'm explicit. Before I was using annotations, meaning, hey, by default, I will return those 200, and that was implicit. Here I'm explicitly telling Spring, hey, return a 200, and put that into the body. Now the next method is a bit more interesting, because now we need to extract the ID, and well, there is an API for that. So we do rec.path variable ID. We transform that into long, because otherwise that's just a string. So again, before we did that implicitly, we just add an annotation saying path parameter or path variable. I don't remember. I never remember. And it was like transformed into a long by Spring. Here we need to do that explicitly. So there is more work, but if you value control over ease of use, then probably you will find this better. And that's all. So let's try to make this work, because hey, I mean, I changed something. I just want to make it work. And so let's check it. So I still have the cache. I'm very happy with the cache, and I will just like check it again. And yes, cache missed because I restarted the JVM. The cache is called again, so I need to call it the second time. And of course, now I have a hit. Also, something that might be interesting, if we ask for the endpoint that loads every entity, then all those entities will be put into the cache. Here we have like 5 puts, and if I ask for an entity that we didn't request before, at least individually, then we see that we have all it. So here now we have the cache that contains all entities. So it still works. We are very happy, and we didn't do anything regarding reactive yet, but it's a step in the right direction. The next step is actually, there is a pattern that seems to be emerging, at least on every sample on the Spring sites, you will see it, is you would put this code into a dedicated class called a handler. So I will just like put this class into a handler. Here is just like an inner class of the person routes. It's still the exact same code. It allows me to just like make it a bit nicer. So you have the handler code on one side and the routing code on the other side. At this point, I don't believe it's necessary to test it because it is just a simple refactoring. If you've got any questions at any point I forgot to mention, please ask me. It will take a bit of delay for the questions to reach me, but I've been doing like online talks for like 15 months, and the problem is talking to my screen is very boring because my screen doesn't answer. So that's why I asked Carlos and David just to stay in the stream so I could look at them and I could see their face. And thanks for having done that. I mean, not everybody is happy like letting their camera on during like 1 hour and whatever. So really, thanks a lot. Muchas gracias. So if you've got any questions, yeah, just let's this talk be as interactive as possible, at least for me. Yeah, and the next step is actually we can. Oops, sorry, wrong tab. I can do a bit better here. Imagine that we have like a lot of routes. We would have like many beans, and this is not very interesting codes. And if we have different components or whatever, or modules, not Java 9 modules, like Spring modules or however, I mean, how you want to package your code, then you could have, yes, don't be shy. Then we might want to put them all together. So although it's possible to have different beans for each runtime function, we can also put them together. And that's what I want to show you here. And here you can see it's still the same stuff. So you would have a path, and then you would have a builder. And under this path, you would build. So under this path of person, you would get all, and you would get the ID. Just I want to try it because here it's a bit harder refactoring. If you are using Kotlin, it's even better. We have a Kotlin DSL. I mean, Spring has a Kotlin DSL, and the code looks even leaner and better. So I believe that's one of the advantages of using Kotlin in that case. Let's get me back to the one. It still works. I still have like 0 hits and 1 miss. And if I redo it, normally I should have like 1 hit and 0 miss. Yes. So it still works as expected, but you see now I'm still using Spring WebMVC, but the code doesn't look like the usual Spring MVC, the Spring MVC that I wrote like 4 years ago. It's a different way to write the application, but the engine is still the same. It's still the good old Spring MVC. The configuration, however, is what they call functional. I'm not sure you could call it functional, but at least it's, I would say it's explicit. At least it's much more explicit than through the old annotation stuff. You might like it, you might dislike it, but that's the way it is. And now I believe we are ready. I believe that we did everything we could. And now I will do the hardest part. I will migrate to Spring Webflux. And look, folks, this is what I have to do. I replace Spring Web with Spring Webflux. That's in the POM. And I change the package. The class name are exactly the same. So it's actually quite straightforward. There is a slight change. So here, the only difference is now we are using reactive types. So instead of returning a server response, we are returning a mono of server response. And of course, in that case, we know perfectly well that it's not 0 or 1 element. We know perfectly well it's 1 element, but still we have this wrapper of mono because that's the expect type in Spring Webflux project. Let's start to check how it works, and I need just to move it here. And it might take a bit of time, and of course I was too fast, so I need to compile it. And yes, now it will be working. Now it's time to check if it still works. Yes, it still works. We still have like the cache puts on the first call and the cache hit on the second call. And remember what I told you just previously during the slides. Now, one part of the application is actually reactive, the controller, route, front end, however you want to call it. And the data access port is not reactive, it's blocking. So our application, we cannot call it reactive. That's just the first step. So if we really want our application to be reactive, we need to migrate everything. And I told you the previous step was pretty easy. The step of migrating data access from imperative to reactive is not easy, it's not fun, and we will lose functionality. We will lose the cache. Why so? Well, there is something called Hibernate Reactive. It's brewing, but right now it's not released. At least it's not integrated into Spring. So we need to change a lot of things. The first thing we need to do is no more Spring data, or at least no more Spring Boot data. We have Spring Boot data R2DBC. Why? Because JPA is not reactive. So let go of JPA. When we let go of JPA, we also let go of Hibernate. When we let go of Hibernate, well, guess what? We lose the integration with caching of Hibernate. So we change from Spring Data JPA to Spring Data R2DBC. We lose caching, and we need to change the way we access the database. So here, I'm moving from H2 like standards to R2DBC H2, which is just the same runtime, but with a reactive access. And that's only the POM, because now we have all the rest to take care of. If you have been using Spring Boot, or if you are just familiar with it, probably you noticed we didn't care about creating the schema. The schema was created by Hibernate directly because, hey, like Spring Boot, so hey, it's a Hibernate project, let's call Hibernate, blah, blah, blah. It reads your entity, it creates your schema. You might say it's a good thing, you might say it's a bad thing. Well, it's how it's done, and now we don't have it anymore. So now we must provide the schema explicitly. Of course, it's not that hard right now, but not fun. Second stuff is, well, Spring Data JPA section, we need to remove everything because, of course, now we don't use Spring Data JPA. So, well, you can keep the configuration, but it will be useless. And the rest is also quite different. So no more Hibernate annotation, no more like JPA annotation. we need just to provide the ID for Spring Data R2DBC. That is, well, not bad, not that bad. We must add the enable R2DBC repositories, and that, folks, to be honest, I have no clue why, because it could infer, hey, we have that in the class path. So probably it's because there is no Spring Boot starter for that. So I don't know why there is no Spring Boot starter for Spring Data R2DBC. I'm not part of a Spring team, but yeah, this is how it is. The repository is actually quite easy. You just need to change the super interface. So you move from JPA repository to reactive sorting repository. That one is actually close to a no-brainer. You just need to find the right place. And now it's a bit of a change, but not that much. So I don't know if you remember, I didn't mention it, but we went, when we were only in the purely blocking modes, we were having OK.body. When we had Spring Webflux and blocking data access, we add body value. And now we get back to body, but we need to bridge between what the repository returns and what body is expecting. So basically, we need to call from publisher and put the person, the class type. And why do we need to put the class type? Because of type erasure at compile time. And the rest is, well, if you are happy with these states, I believe that the rest is pretty easy. Now let's check that it still works, because now we have done a lot of changes. And also for fun, I just changed the code this morning. I updated it. I'm using the Pennabots. I'm always doing that just before a talk, just to be sure that you've got the latest and greatest. And of course, it's a risk. And now you can see I'm using Netty. And I probably don't have the right version, because here it tells me about that. Yes, I forgot something. I forgot to move the Git repo to the next version. And now I can try it for real. So much better. Much better? Well, much better if you accept that you don't have caching anymore. That's much, much better. But now I have everything that is reactive. And well, since it still works, of course, I cannot check that the cache is used because there is no cache. But it's still working. I can have the exact same stuff that happened before. And I tell you, everything is non-blocking, everything is reactive. And because you trust me, because I'm a nice guy, though I'm French. But of course, you should never trust me. And actually, you should never trust anybody. You are engineers. You need to make sure that, yeah, you need to make sure that when somebody says something, it's a fact and not just bull crap. And in that case, I want to prove you that it's actually reactive. And how do we do that? There is a super nice component called block hounds, and block hounds will actually sniff the calls that are supposed to be reactive and are not reactive. And actually, there might be like blocking calls on dedicated threads, but there should be no blocking call on the main event loop thread. So we will just add this additional dependency, and we will add it at the beginning of the application. And it's easy. You can configure it. It's already integrated with Project Reactor. It's integrated with RX to Java. You can configure it with your own reactive framework. For example, if you are using Vertex, you can tell it, hey, this thread is actually not the target of blocking calls. This thread, it's okay to have blocking calls. It installs a Java agent at runtime, meaning that you shouldn't do that in production. And every time it encounters a blocking call in a place where it's not supposed to be blocking, it will throw an exception and like stop your application. Well, at least throw an exception, not stop your application. So just let's try it. And let's check that I'm not lying to you. Again, though I'm French. Don't trust the French, especially when we lost the World Cup. Here it still works. Now the question is, how can we be sure that Blockhound is doing its job? Well, it's in one of the next steps. Before going that far, I just want to add an additional feature, a feature that was not there. What I want to do is I want to like return a 404 if the entity is not present in the database. And the reason for that is I want you to get familiar with how it's done. No, not here. I want to go to my routes here. Because I believe that's very interesting. You remember I told you, hey, we are using Reactive now, everything we have a specific API. Well, yes, everything will have a specific API. Ifs, for example, ifs else will have a dedicated API. You cannot just use simple if else because that code will probably be blocking. So here, this is how you read it. You will do the repository find by ID. And now imagine that there is no such entity into the database, meaning that the mono of person will actually be empty. If you say, hey, if mono of person dot check if empty, you will be blocking. You will actually not be subscribing. You will be like digging into it. It's not great. So you need to pass an additional like kind of like if statement, but in a reactive way. And it's called switch if empty, meaning that whatever subscribe to this will actually be doing this, will be, hey, like if this is empty, then it will get the value from that. And again, here, you will like create a mono of error and you pass the error that you want to create. So here I pass a 404. Whether a 404 is warranted in this case, I leave it up to you. I'm not a REST guru, but for the sake of the demo, it's good. So let's check. It still works when the entity is present and it throws a 404 when it's not present. So this is something that I added just to show you that, yes, now the if-else, they are not super great for codes that is supposed to be reactive. At this point, I want to get back to the previous situation. The previous situation was, hey, I had caching, and now I don't have caching anymore. So what I will be doing, I will add a service layer, because it's not a real Spring project if you don't have a service layer. Remember, always have a service layer. And in case you didn't notice it, I'm joking. It's just that I'm not smiling, but it's a joke. You can add Spring project without service layer. Here, it's just that between the routes and the repository, so here I was using a repository, now I'm using a service, and I'm injecting this caching service. This caching service just is actually checking into the cache and returning the result if it's in the cache. So what Hibernate did for me before automatically, now I have to be explicit about it. And let's see how it works. I will check in the cache, and if the person is not in the cache, then I will check into the repository, and if it's found, so if something is found in the mono in the database, so if the mono contains something, then I will put it in the cache. Otherwise, I will just return from the cache the person. And the find all, on every entity, will put it into the cache, just like Hibernate does. Now let's start this. And remember, I'm using Blockhound. So normally, if I do something bad, and I should do something bad because I told you, hey, probably if you do like something like this, it's not super reactive, it should throw. So now it should be a good time for it to throw. And yes, it throws. It tells me, hey, you did something wrong. Oh, and then you need to check the stack trace, which can be a bit long. And here we can see the first line where something bad happens in our code. And actually, it's not even at the if port. It's here. It's at this port that something is throwing, because get is a blocking call. So we are using like blocking code in a place which is not supposed to be blocking. So we need to rework this port. And fortunately, there is a way to access Hazelcast in a non-blocking way, but we need to bridge with Project Reactor. So in that case, it's quite easy. I'm not saying in every case it will be quite easy, but in this case it's quite easy, because here we have a getAsync function. And this getAsync function actually returns a completion stage. So if you are into concurrent codes on the JVM, you probably know about completion stage. I think it's Java 8, so it's quite old. And we need to bridge this completion stage to Project Reactor. Fortunately, there is this mono from completion stage. So now we have our bridge. And again, we don't do if, we don't do else, we don't do never. What we do is, okay, here we have this mono from completion stage, meaning that if it's not empty, if we actually have something in the cache, we will call the do on next, because do on next is called when we have an element. So what we will be doing if there is an element, we will just log. Now, if it doesn't contain anything, we will switch. And we will switch to repository.findById. And that is fine because it's actually reactive. And if this is not empty, then we will do on next. We will put it in the cache asynchronously. And that's what I told you. Like here, you must be quite trained to understand the exact intricacy. And here we have only a simple flow. Hey, I look in the cache. If it's in the cache, I return it. If it's not in the cache, I look in the database and I put it in the cache if it's not empty. This is very, very easy flow. And if you're not used to that, it's already, in my opinion, quite complicated. And again, for the find all on every element that it finds, we will put it in the cache asynchronously. So let's see if it works. So now block Hound should be happy if I didn't do anything bad, because my code should be fully reactive. So let's check. Yes, it works. I'm happy. And we can check that something happens in the cache, because now we are logging. Yes, person with ID1 set in the cache. That was a previous code. Person with ID1 found in the cache. And now we can like have every person in the cache like before and check for like ID2. And person with ID2 found in the cache. And now we get back to the original like state, but now everything is reactive. So complexity on one side, but better scalability and probably better usage of resources on the other side.
Hey, Nicola, yes, one question, if I may. And maybe you are going to mention it later, but is it there a way to kind of abstract away the getting from the cache that you're doing and putting on the cache, like having some memoized function that you could reuse and just leave the business code that you had before? Or Java doesn't put up with it well? You don't have enough functional mojo in Java to do that?
Here, it's just a consumer of person. So imagine you could like extract this code and put it in a functional interface or as an attribute or whatever you want. And if you find that it's better, and I believe that might be better, you can extract it and like put it in a place where it can be reused. Yes. I would probably do it here. I probably wouldn't do it here because it's really like quite easy. For one-liner, I think it's not necessary. Here, it should be a one-liner. It's just that I have this logger because I wanted like to show you how it worked in the log. But yes, nothing prevents you from like creating consumers or whatever in. I mean, it's just functional pipelines, so you can do whatever you want with it. It's a good question. And actually, no, I'm at the end of my presentation of my demo codes. Now I just want to have like some like conclusion. So if you find yourself in the situation where you need, not you want, you need to migrate to Reactive, I would advise you to migrate to functional APIs first, because you will like, it's just a strong signal that it's different from what you are used. And of course, you can still do like annotations reactive or blocking functional. It's just that in that case, I believe the annotation are in our mind, at least in mind, like associated with Spring MVC, and functional might be like associated with Webflux. Remember, when you create your functional pipeline, everything needs to be reactive. If you have one blocking code, well, it's not reactive anymore. So in order to ensure that, use Blockhound as much as possible. Just don't use it in production, but for all your tests or whatever, use Blockhound. So perhaps you could have like 2 entry points or a parameter or whatever, but use Blockhounds. It's definitely more work, but it's not impossible. In general, what I do when I'm faced with something that I cannot do, I call my favorite Reactive guru and I ask him, hey, how can I do that in Reactive? And I definitely would advise you to have one such person that you know. If you were in Kotlin, but you didn't choose Kotlin, you could use coroutines to make the codes much easier to read. I mean, it would look like imperative codes, so lines after lines, but everything would be non-blocking in such a scope. So if you're on Kotlin, check the repo, and if you're not on Kotlin, check the repo anyway. It might give you some tests for Kotlin just for coroutines. And if there is something you need to take out of this talk, is please don't use Reactive because others do. Don't use microservices because others do. Don't use DevOps because others do. Don't use Kubernetes because others do. Just use because it makes sense in your context. You're an engineer. You are supposed to take like enlightened decisions and not follow the herd. And that's a bit frustrating when right now. It's because I see a lot of people, especially when you do talk at conferences, you attend conferences, you see a lot of people saying, hey, Kubernetes, microservices. No, please, no, don't do that. Do it because it has more pros than cons, because the return over investment will be positive. So Reactive, great if it makes sense. And the last slide, and yes, if you like, you can read my blog. I publish every Sunday evening. You can follow me on Twitter. That's always nice. I can always show my friends that I have more followers than them. But of course, you are not like it's not. I'm not supposed to tell it, but it's just fun. More important, if you got interested, you want to try it. If I was too fast or you missed something, the code is on GitHub. Just like clone it, store it, do whatever you want. There is, as I mentioned, one branch for Java, one branch for Kotlin. And though the talk was not about Hazelcast, if you want to know more about Hazelcast, just like join our Slack, ask questions, and we also offer free training. And that's all, folks. So now, if you were too shy to interrupt me, is the right time to ask more questions.
So just make sure that you are start typing. But in the meantime, I would like to ask another question, if it's okay to you, Nicola. So I was wondering, because I keep thinking about abstracting away all the calls and putting Hazelcast as a cache for every call, because it seems pretty transparent the way to do so. So you can benefit from the cache. But I have one question. So since you created some methods to fetch one element and to fetch a collection of elements, I was wondering if Hazelcast has a bulk operation to fetch like several elements in one blow, to say so, and
Yes.
and how will it behave in the asynchronous API if you request a bunch of elements from the cache and only some of them are missing and some of them are present in the cache? How could you recover from that in the API?
That's a good question. I have no clue because I never used it, but we can check that get a sync. I mean, I can check with you. So it's 7. And I have a get async. So no, the only async that I have is one ID by one. So in the blocking world, we have a get all where you put a set of keys. But in the reactive, well, not reactive, in the non-blocking world, in the future world, we've got only like async for one single key.
And okay, I see. So if in the event that you could compose several of these completion stage, they are not going to be like composed into one. There's no way to do that under the hood. So we can send the bulk operation.
Well, we are compounding several issues. The thing is that Hazelcast is distributed by default. So here it was easy. I had a one single node, but normally you would have a cluster of several nodes. And then you would like ask, hey, one node, hey, like give me all the entries that has all those IDs. And so the node would just like contact the other nodes and ask them and aggregate the result and stuff. So here we are compounding multiple problems, and it might be the reason why that there is no get all async.
Okay, I see. So I guess my question can be rephrased in like I guess there's no completion stage implementation by the Hazelcast API that will aggregate themselves. For instance, if you are using the and then complete and all that stuff, that they aggregates themselves in some way. If you toss all them to the Hazelcast, it will aggregate all the results in one blow.
I will search for async. So I don't have, well, there are not that many, but yeah, I have get async and I have put async. No, there isn't.
At any rate, it might not be worth it, because if the response is fast from the cache, then
it might be worth it. It's just that we have, like everybody, we have a limited number of engineers, and actually, so far, I don't believe we've got that many requests. However, Hazelcast, I didn't mention it, but it's open source. So if you are missing something, we will be very happy to help you contribute. And it doesn't need to be complicated. But if you have a specific use case and it's in line with our product management, of course, then just contribute.
Okay.
I will put back the slides with the references because that might be interesting to people. Other questions? You are muted, David.
Yeah, that's true. I was asking if anyone else has any questions for you.
Well, come on, folks. Questions. Keep them coming. Otherwise, that just meant I talk to my screen again. Not great.
Well, in any case, there are a bunch of people that usually see the recordings of these talks afterwards. So I think that they will be able to reach out to you via Twitter
Yes.
or any way in order to ask any questions. So,
my DMs on Twitter are open, so if you are shy and don't want to ask questions in public, just reach me out on Twitter and I will do my best to answer. Worst case, I will direct you to somebody who knows more than me and has the answer.
So, well, thank you very much,
Thanks a
Nicola,
lot.
for your talk, for being with us. I knew that there were a bunch of people that was following your talk in JNation, but they were willing to come and attend or see the recording of this talk again in order to go over the same concepts again. So I think that probably some of the people that are following us or the people that will see the recording will reach out to you in the following days. So let's keep to it. Okay, and now, as a final thing, we are going to raffle a couple of JetBrains licenses that we have. So in order to keep it short, what we are going to do is we are going to raffle those between the people that are interested in those. So any one of you that want a license, that is interested in license, just please send a message, put a comment in order to see how many people are really interested in being part of this raffle.
Okay, so, and in the meantime, maybe you can say it in Spanish, David. Also.
Okay, I know that there were some people following us in English because at the very beginning, with my introduction in Spanish, someone was asking if the talk was going to be on Spanish or in English. But anyway, I will also repeat it in Spanish. Decía que
no hablo español, caballeros.
Vamos a sortear 2 licencias de JetBrains. Entonces, también para dar un poco de tiempo, porque entre que yo lo digo y que os llega a vosotros hay un margen de tiempo, vamos a sortear 2 licencias de JetBrains entre aquellos que estéis interesados. O sea, que los que estéis interesados, pues simplemente dejad un mensaje en los comentarios. Rafa ya ha dicho que es un candidato. Si no hay más, Rafa, el sorteo va a ser rápido. Y si no, bueno, pues lo sortearemos en próximas sesiones. Vamos a esperar un poquito más. Jero, nunca hemos dicho si podemos los miembros de Madrid Jack, pero bueno, parece que no, o sí, no lo tenemos claro. Bueno, si no hay nadie más, pues Jero puede. Jero, te ponemos a la fila. Nos ponemos los organizadores los últimos. Okay. Anyone else interested?
At any rate, I think we can in the meantime say goodbye to Nicola. I think we can release him from being here. So thank you very much, Nicola. It's been a pleasure to have you here again, and it's been a super interesting talk. I've taken a lot of things to play with, so I hope everybody took advantage from your talk as well. So thanks a lot
for invite, and I hope that we will meet next in person in Madrid, eating tapas, and that would be nice.
Yeah, of course.
Yep, looking forward to it.
You know that you have our doors wide open, so anytime soon.
That will be very nice, but if the borders are closed, your doors might be open, but Spain doors might not be so wide open.
Yeah, it's okay. We have our ways. We have our ways, Nicola. We know people.
That's good.
We know people in Barcelona, Jug, that might smuggle you through the border.
Okay, thanks again. Have a good evening. And any questions, send them my way. Bye-bye, folks.
Okay.
Bye.
Likewise, Nicola. Bye.
Bye.
Bueno, entonces creo que Rafa,
Javier,
te quedas.
Javier dice que sería raro, lo que no sé es que sería raro, Javier.
No sé, que sería raro que Jero se lleve la licencia.
Que pudiésemos los organizadores o no sé si...
Yo creo que Jero se lleve la licencia sería raro. Así que no sé si Jero se ha abierto una cuenta que ponga Javier Martín. En cualquier caso, no sé si Javier Martín está interesado en la licencia. Si no, pues Rafa, tienes una licencia de JetBrains. Y yo creo que te la has ganado ya por la participación. Y no sé si Javier está interesado en tener una licencia o no. Y si no es así, pues vamos a dejar las licencias para otra sesión en la que haya más gente interesada. Javier Martín está también interesado, así que una licencia para Rafa y otra licencia para Javier, que pues son los únicos miembros despiertos al final de la... o por lo menos con acceso al teclado y al chat. ¿Vale? Así que si podéis poneros en contacto con David, dejadle
un mensaje o bien por Meetup o bien por correo electrónico o bien por Twitter y simplemente lo que necesitamos es que nos dejéis vuestra dirección de correo electrónico para mandaros allí la licencia, ¿de acuerdo?
Vale, y sin más, pues ya recordaros que mañana tenemos otra sesión. David, no sé si lo tienes en la pantalla disponible para...
no lo tengo, pero casi. No lo tengo, pero casi.
Vale.
Lo preparo. Básicamente recordad que mañana lo que tenemos es una sesión conjunta con Andrés Almiray. La sesión de mañana sí será en castellano porque, bueno, Andrés es, aunque vive en Suiza, Andrés es Java Champion y es venezolano, con lo cual no se le ha olvidado todavía el español, que sepamos. Entonces, voy a compartir la pantalla.
A ver qué compartes.
Voy a compartirla con cuidado.
Eso sí.
Con mucho cuidadito. Ahí estamos. Vale, básicamente la sesión de mañana va a ser una sesión sobre JReleaser. Es una sesión conjunta, la vamos a hacer, como es online, vamos a hacerla en conjunto con 5 Java User Groups de España, Coruña, Vigo, Málaga, Barcelona y nosotros, con lo cual seremos unos cuantos. Es un poquito más tarde para poder dar tiempo a sincronizar el mejor horario para todo el mundo. Y básicamente, bueno, pues será una sesión sobre una herramienta para automatizar los despliegues, para automatizar los despliegues, no, para automatizar la liberación de versiones. Entonces, bueno, si no conocéis a Andrés, es un gran speaker y yo creo que va a estar muy bien la charla de mañana, así que si podéis hacer un huequecito, apuntaros. Y nos vemos mañana a las 8, ¿de acuerdo? Pues nada, un saludo a todos.
Venga, gente, nos vemos. Hasta luego.
Chao.